Hello, thank you for sticking with us. We know that we are holding you hostages before lunch, so we also hope that you have an appetite for our talk that's about system failure and what we can learn about it. So what is the cost of not performing? Well, I guess even if you are not in an e-commerce specific segment, you already know this number. They are pretty old and still valid, actually just a lower bound. And things are not better when we think about other aspects like security that can affect our business continuity. And we know that loss of trust, loss of performance, it always adapts to a loss of confidence and profit at the end. My name is Gabriella Brodi. I am a lead solution architect at TerraSky, global solution integrator. We work with our customer with hands-on work and consultant. And I'm really glad to be here today and co-present with my colleague, Elad.
Thank you, Gabri. My name is Elad. It's a pleasure to be here the second row. I am head of public cloud and AI at TerraSky. I'm a software architect for many years, and I am an AWS ambassador. Thank you so much, guys.
OK. If you look at this, maybe with a little bit of drama, but I guess you can recognize one of your architecture. Like our distributed system, they comprise of a number of microservices that are interacting through mixed stack and mixed API call, gRPC, TCP maybe. Whatever is your poison, it's going to be there at some point. And of course, they are using multiple resources that are usually available across a different number of cloud. And there are different teams that are managing this team, and a number of pipelines, usually pretty complex, that will help with deploying and keeping all of these things working. So pretty easy, no? What can go wrong? Well, it looks like a number of things. This is an example from a couple of years ago where Shopify website went dark for 45 minutes right before Black Friday. Pretty scary. And this was a team of world-class engineers. They are running cloud-native Kubernetes workload. And yet, there was a failure with one of the workloads, and this thing happened. But not everyone works with the bleeding-edge technology. I guess most of us will still deal with technical debt. It's a bargain chip at the end. So this is from one of our customer engagement. The team went through a modernization effort, and it was great, adding API gateway to provide rate limiting, MTLS, having authentication, authorization, all of the great things that an API gateway can give you, and put and kind of embrace both legacy and more new backend services. And of course, they also have a circuit breaker. That was great. And while we were doing testing with them, we discovered that one of the circuit breaker, when it was kicking in, it was connecting directly to the backend service in HTTP. And it was transferring pretty sensitive data. Now, the cost of finding this at the wrong time would be really big. Luckily enough, we were able to catch this earlier. All of this happens because as a developer, and I started as a developer, I am guilty of this. You know, when I remember not thinking at the beginning of networking, of latency, of the bandwidth, of the cost of transferring data. It's kind of a second thought. But it's going to catch up at some point. Like you have to deal with fixed bandwidth or even with latency and jitter that come out of the blue. And what about security? Think about the problem with our customer. Do we know that everything is really encrypted, that we are managing and transferring secret and rotating them accordingly to best practices? Can we be sure of that? And even when we think about Kubernetes, it's great when you have good deterministic thing. Auto-healing is perfect for that. But if something is not good, if something is bad, well, I guess we are all familiar with something like this, where if something is broken, just keep restarting broken. It can't fix a wrong network partition or a wrong architectural choice. So even Kubernetes can help so far. And this is the illusion of stability that we have while we work within the distributed system. Every team builds and deploys independently, and we think, oh, wow, we are so good. But sometimes this independent actually brings fragmentation. And fragmentation means, for example, let's take observability, that different teams with different stack are propagating information with different context. And sometimes there are blind spots that will not help in the moment where we need it the most, when we need to do root cause analysis and understand what is going wrong. So this complexity that sometimes convince ourselves the system is so complex, it must be strong. In reality, we know that thing will happen and system will fail. Do you have an idea what can we do to fix this, Elad?
So I'm not promising anything before lunch, but I have my theory. My theory is that when we spoken about chaos, and again, it's really not a new term, at least 20 years or more. We always talk about, okay, this is another variation of a failure. And I'm telling you it's not. So let's take 3 examples. The first one, again, both of us, developers, when I have a bug, I will fix the bug, I will add a unit test, I will ship it into production, but then I will continue to the next thing. This is not how you handle chaos. But then if I am a good developer, I understood that I need to check the system. So I'm going to my team lead, I'm going to my architect to say, let's do a design review, let's use chaos for it. He will not say just do it. He will tell me, okay, great. Let's discuss in the next sprint or 2. We'll have more time to discuss about it. And guess what's going to happen? There is not going to be any more time because our backlog is full of other tasks. But then I will try again. I will go to the SRE or DevOps team and tell them, guys, you need to wake up. Something needs to be changed. They're going to just tell me, are you really going to poke my production system with the random failure? Thank you. Do it in your next company, not here. So this is why exactly when you speak about chaos, it's not a new term. But people are not using it enough. They're not using it enough because chaos engineering is not just randomly come to the morning after drinking your coffee and decide to unplug the system. Remember, if you're Elon Musk, you can do it, but most of us will not do it. So if is this not the case, like every engineering practices, how we will solve it? We'll solve it by adding a logic to the madness, thanks to you. The experiment life cycle looks like that. We have a steady state where everything is working okay. We have our baseline. Then we have our hypothesis. Let's say, for example, my service, because it's running in cloud, there is a chance that I can have some kind of network latency. Let's have 250 milliseconds. I will design the experiment and schedule it properly with production. Again, no surprise. I will verify, find if there is a gap, fix it, and continue again and again. Now, this is really defined how to get a logic and structure into this chaos madness. So this was great. We spoke about philosophical part, and again, let's be practical. This is an example of a recipe. We use Kubernetes at the heart of the system. We use Argo CD to make sure that we have one source of deployment by making sure that all of our orchestration into our environment will not be split between Jenkins and manually or a Terraform, whatever you want. You have a GitOps. This is the revision of the deployment. And you utilized Kubernetes to make sure it's working. Next, let's introduce Pixie. Anyone knows Pixie? Yeah? Amazing, guys. So I want to introduce Pixie as an instance of observability. And this is, Gabriella, I think, really, really direct to what you have said. We see that developers don't care about anything beside their code. They don't want to get a task to go to your page and add JavaScript that will intercept to get the observability to the front end. They want us to change the deployment and add some kind of arguments that will listen to this deployment and this and this. They don't want to speak about multiple solutions. They don't need to do anything because what we're doing here, it's an eBPF-based instrumentation agent that run in all of the nodes, and you're going to see an example in the demo. There is no code changes. You are able to intercept both metrics, traces, and log. What's really nice that it can hook to your observability platform because they have OpenTelemetry exporter. And most of it, which is super important, it has a visibility between layer 3 to layer 7. So anything between my node is crashed to my SQL query not running good, I will be able to see it in one place. This is super important. But guys, we talked about Chaos Mesh. So Chaos Mesh is a CNCF project that really gives you the ability to create simulation of chaoses behind just shut down this EC2 instance. It's orchestrated, sorry for my English, orchestrated at failure at the whole system, again, at the node level, at the kernel level. It has multiple kind of failures. It could be pod failure, JVM. It could be on-prem. Whatever you decide, they have a default suite around 55 kind of failures. And it's really practicing a safe way to handle this experiment. But all of it is nice. Let's see a demo. And this is live one. So let's hope for the god of demos, it's going to work. So I have provisioned my EKS server. Everything is great. I have an e-commerce application. Let's start simply by see Argo CD if everything is OK. Is it big enough? Well, I don't think so. I'm hoping now it's better. OK, so this is my Argo CD. We can take a look. This is microservices of shopping application, checkout services, currency, email services, all connected to one deployment. It seems like everything is healthy and synced. So we agree everything is OK right now. Let's see application. Let's try to buy something in our e-commerce application. All right, so this is our online boutique. So Gabriella, I will select, I need sunglasses. Not sure for this season, but I need sunglasses. What do you want? Do you want me to add something else?
Yes, please.
Please. OK, so let's head hair dryer. Amazing. So now let's do checkout. And we place the order. So eventually, we're here to serve our customers. If we're talking about the e-commerce application, we want to be a slick design, a best UI UX, but of course, we want the latency to be as low as possible. As Gabriella just said, every time, every fraction of a second, there is delay, there is good chance there's going to be churn, and they will not complete your flow, all right? So now the baseline is amazing. Now, let's see what's happened behind the scene. We introduced two components. One of them, as you see here, it's a Pixie. The Pixie, which you see as a visor PAM, is a data collector deployed as an eBPF agent, and it's responsible for the instrumentation at the kernel level. And why do not interact with the code? Because it has an access to everything goes to the kernel. He can intercept every packet, and again, from layer 3 to layer 7, and orchestrate the data by himself. It has its internal graph database, and this is super, super nice. And you're going to see it in action. Now let's take a look how it works. Let's open a Pixie managed service. It's called Cosmic. You can see that I have multiple services. Some of them do not work. Some of them do. But I want to show something very, very cool. If you write flame graph, this is, and not this one, flame graph, you're going to see something very, very nice. Are you familiar with this one? This is an amazing way of viewing the stuff aggregated and really understand the root cause analysis, for example, for performance. Because keep in mind, we can see the complete stack from, I will not say the bare metal, but from our orchestration layer to the application layer in one place and understand where the problem came from. It's super amazing. And again, without doing anything. Now, let's talk about Chaos Mesh. chaos mesh, again, as we see here, it's a daemon set. And it's a daemon set running in privilege mode because we need to interfere with the way the system behaves. So for example, if we want to do a network latency, we need to hook into the node itself IP table to simulate it, yes? And again, it must be running in a privilege mode. So let's create a token. I will just copy paste, token for an hour. Maybe it's already cached in my browser, but let's see.
Yes.
No. Of course, it's not going to be. Let's call it blah, 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 like always. And you see chaos mesh. We go to experiment. You're going to see that you have default one of them. For example, you can have network attack and create a delay. And also in the delay, you can set up if you want latency, if you want jitters, correction, multiple things you can have. And you have at least 50 to 60 combination you can do. And of course, it also has support for the host if you have a data center. But this is chaos mesh. Let's see it in live. So Gabri, I think that I would like to get, as we said, our baseline.
250 for then?
Just let's see the baseline. As we see here is the baseline. You see it's amazing. Guys, take a look. The total wait time between the median to the max is less than half a second, which is great for every commercial website. Now, Gabri, as you said, is it okay that we introduce some kind of a chaos?
Yeah.
Okay. Let's take a look at the chaos. I just randomly selected the Brodi catalog service. And I just added the latency 250 milliseconds. This is my hypothesis. I believe, because I'm naive, everything is going to be OK. Let's try it. I'm going to apply it. And this is so nice because it's just CRD. So I'm just going to apply it. In a few seconds after, in an experiment, you're going to see it provision, new experiment. You're going to see the event it provisioned, the CRD, and the status of the run. And of course, as we said, we need to analyze, which means running the A/B benchmark again. Let's run it again. OK, let's see. I'm sure everything is going to be OK. Oh, OK, so it's flipped. But you see it stays at the median because the maximum, again, it's false positive. We can still see that the median, Gabri, is 580 milliseconds, which is OK. Can we finish now, maybe?
Now, I'm curious. I want to do one more.
What do you mean one more?
One more. Let's add the same latency, but go to the front end.
To the front end? OK. I'm sure, guys, everything is going to be OK. We're just going to run another one, which is, this is a front of chaos. And take a look. It's the same thing. I'm just going to change the selector. It's going to be for the front of service. So if I added 250 milliseconds, we should see the same. So what's going to happen? Let's see if our hypothesis, our experiments, goes well or not. So I'm going to apply it. And again, it took like a fraction of a second. And now let's run the A/B testing again. I'm sure, Gabri, it's going to be OK. Tell me what you think.
Maybe
OK.
your network.
My Wi-Fi is OK?
Lost, I think.
No, Wi-Fi is OK. It seems like it's running.
OK.
But we don't know what's happening. For some reason, it's taking much more. But guys, I just changed the latency and added 250 milliseconds.
Like
What's happened?
Yeah, just different service.
Wow, something happened. So I just changed the service, added a driver network latency of 250 milliseconds, but now my website latency is 4 seconds, which is, as you know, for e-commerce, it's shut down, exactly like the server down. No one will use the website. If every HTTP request, AJAX request will take this amount of time. So my question to you guys, this is very, very strange. Our system is not predictable. Why 250 milliseconds, Gabri, caused us 4 seconds?
Let's call an SRE.
Let's call an SRE. So we develop an SRE agent. This SRE agent will orchestrate and run group action from Pixie to get all the data, the network, the traffic, the relation between the services. It will get information from the logs. It will capture it, and we ask him what's happened, what's caused this delay. So wait 2 seconds to our analysis. And what you're going to see here in a few seconds, or not, let's pray to the God of demos, you see that we have explanation. We understand that the delay in a front-end service is much higher because the front-ends make multiple parallel requests in a serial way into various backend servers. And as you can see here, we got more explanation about how it's caused and the statement. And from now, we can really, really understand how chaos can help us, because we can mitigate ahead of time this kind of scenario. Gabriella, what do you think?
I think this was amazing. What do you think? Was a nice demo. I think that this, the ease with which we were able to poke in the system and get insight on the behavior was just amazing. Now, we used to celebrate all of the 9 of uptime that we can get, but at some point now, this is kind of a fear. When there is a change, what is going to happen? When is the system going to break? So we need to have this shift from thinking about preventing to actually embrace the failure. And this is what Netflix introducing Chaos Monkey was doing. Not chaos per se, but a way to engineer chaos so that we can poke in the rib our system and understand how it will behave under circumstances of stress. And once we know this, we can incorporate this learning and be more resilient. It's not only about preventing, but it's really important to understand how can we adapt when something goes sideways. So we will leave you with the idea, with the thought that the path to resilience goes through an engineered chaos. But don't forget, it's not all about the system. There are humans behind this. And so train, rehearse, and be kind to those that run into the chaos or run the chaos. This is it.
Thank you, guys. Thank you so much.